All right, I'm going to give a really quick tour of the virtual ontology system that I've been prototyping just to demo it so you can get a sense of it. Everything's contained in a GitHub repo. I'll post a link to it so you can clone this and you'll see the same directory that I'm in right now. What makes all of this work is Claude code, but any system where you've got an LLM and tool access and things like that, you could abstract it away to that. So this started with the project I was doing for work around manufacturing execution system analysis. So what I did is I created some dummy MES data so you can see what it looks like. So this is, and I can share the code for a separate repo that's got the generating code for this, but this is kind of reflective of generic MES data. So we're producing various beverages, energy drinks, soda, etc. But you can see these are only the first 10 lines of 2 weeks of data collected every 5 minutes. You've got things like timestamps, production order, the manufacturing line, equipment ID, equipment type, the product ID, the name, the machine status, downtime reasons. These are very common when you're dealing with production lines. The number of good units produced. This is the quality measure, scrap. The target rate, meaning how many units per 5 minutes should you be able to make. The cost per unit, sale price. You can get things like margin backwards out of that. And then scores that are related to something called operational equipment effectiveness is kind of the generic term for it. Availability, meaning of the planned time that the line could be running. Is it running or is it down? So it's a percentage. The performance score, and then the quality score. How good is your uh, good product to scrap ratio? And then performance is, are you running at the prescribed rate? And then from that, you can derive an overall OEE score, which I just calculated in the raw data. It's just availability times performance times quality. So this is a toy data set, but I think it gets the point across. So how this is intended to work is this is now exposed as a SQLite database with a fast API implementation with a SQL endpoint that you can ping. So that runs separately, all the code's in here to do that. And then the idea is to have an LLM generate SQL on the fly based on natural language questions. And that works often with no additional help, but there are benchmark studies out there that it's still kind of a struggle to do that. So we took this idea of ontologies. I totally ripped it from Palantir and I kind of interpreted it knowing nothing really about it other than that it was called an ontology, understanding the philosophical concept, which is really just entities, their properties, and their relationships, what things exist, and in what context do they exist. And there's different ways of expressing that. And if you read into the ontology, literature in the world of data, there are formal ways of both expressing ontologies and then also storing the data in a linked fashion that makes it very easy to retrieve and traverse. So you'll see things like web ontology language, RDF triple stores, a lot of graph databases kind of reflect an ontological structure. But there's this not so much a problem, but an opportunity that virtually all of the data that an enterprise might have is probably sitting in a Snowflake data warehouse and probably accessible via SQL. So instead of having to re-express it as an intermediate representation, and like an RDO triple store, which I tried and it works, but it's cumbersome. We were thinking that it's probably the right time to just let the LLMs run wild with the right context and do this. So we're introducing this idea of a virtual ontology, which is really just a specification, again, of the entities, the properties, the relationships, and the relevant business context, and then pairing that with a database schema. And they're paired in a way that they can, all the fields variables, et cetera, match. So the LLM can kind of work off the ontology and then get directly into what's available in the database and write the SQL. And it's worked surprisingly well, so I wanted to demo it. Um, the other things that make it work is a fairly lightweight system prompt telling it what to do. And I've also been capturing working queries over time, so I've got some learned patterns. And I'll run it with it just to see. Um, how much better that is, but you'll get a taste of what this can do. So driving all of this is this idea of an ontology specification. And really, if you just Google RBox, TBox, it's kind of like the theoretical foundation for knowledge systems, and it's just the entities, essentially the things that exist in the TBox, like formally declaring them, and then the RBox, which are the relationships and the properties and context are built in along the way. And there's various ways of expressing this. It could be like a simple table that you use. I was using a semi-unstructured markdown file, but we decided that it would be good to use a standard YAML format. So we came up with a template that's also available in the repo, and it's populated essentially by talking with the LLM and saying, look, here's my raw data, here's what's going on. Please create an RBox, TBox using this template. And even with minimal instruction, it does a good job. But that's meant to be an interactive um, step where maybe you spend 30 minutes because you're the domain expert saying, oh no, this is a production line, it's in a plant, we make products on the line, and then all of that kind of gets captured in there. So the ontology itself, or this specification, the RBox and TBox, just very simple, some metadata like what is the ontology we're dealing with, the idea being that there will be other ontologies for other data sources. Um, and you can eventually get them to link up and you can do cross-domain, cross-functional types of analyses. Just a little bit of lineage information. And then this is like the more important part, right? Like what are the classes, the business entities themselves. So you see things like here, there are processes, there are resources. So things like production orders, equipment. You can see in the description, this is like very lightweight business context, but extremely powerful. Um, and it goes on and on. So you can read through this. I'm not going to go through every line, but you get the general idea. So we've got things like processes, resources, events, meaning like this is like the timestamped thing that happened at that time. Reasons, very common in MES data, like what happened at that time if there was an anomaly. And then you've got the relationships. So you say, okay, here's a relationship might be is upstream of. If I've got a packer, excuse me, a filler upstream of a packer. So I'm giving actual, like true physical reality representations, and it's talking about the classes or those T's that we defined above. So it's entirely flexible. Um, and you could either manually create it, you can manually edit it, or you can really just let the LLMs do their thing, and it's really quite good with the minimum description of what's going on. So what you would do is you would just like feed it a sample of the raw data, tell it, tell them like this is manufacturing execution system data, this is what it means, this is how we get to it, this is how it's frequently used. Search the web because there's plenty of examples out there, and it comes back with a remarkably solid foundation to work off of. So additional attributes that are related to each of the different classes or entities, so on and so forth. So this is kind of the secret sauce behind it. And this is something that you would probably maintain in a document store. You could update, you can version control um, as things change, right? So it's dynamic in that way, which is really nice. And then you can add some business rules in. This would be like the quote tribal knowledge that's often talked about. You can bake all of that in the pie here. And here's an example where you might want to do cross-system mappings. These don't exist. These are just like demos, right? Like I might want to link to quality data or enterprise resource planning. Um, if you're in the field, all of that will make immediate sense, but this is meant to be thought about abstractly. It could really apply just about anywhere. And then maybe some common queries just to help kind of bootstrap things. You can delete these, it'll work just fine. And then I have some additional information if there's any terms of art that we'd want to know, because the point is we're driving all the way to actionable insights at the end. And that's again where this whole LLM, this like natural language REPL comes into play because it's able to understand the data, what it means in the context of the business, pull the raw data, do the analysis, and then think broadly about what does this mean and what can I do about it. Um, so that's the ontology piece. The other part of this virtual ontology is the database schema. And again, it's meant to be paired with the ontology spec. And really all this is a formal description of the different fields available in the database itself. So it's kind of it's a one-to-one mapping to the SQL database. but it's using the same language as the ontology. So the LLM can reason with the ontology, then consult the database schema, construct the SQL query, pull the data, do the analysis. Um, One thing that's worth mentioning is that I don't want to blow out the context with a couple queries. So I'm basically I have a little wrapper script, a shell script that we run the queries through, just using curl, and it basically looks at, is this a large chunk of data coming in? And if it is, maybe I'll only feed a sample or a header to the LLM to keep the conversation going. But all of the raw data that was pulled is stored just sideline in a file. And I'll use a tool to access that and either use Python or something to analyze it, all within the LLM. But that's just a way to prevent completely blowing out the context in a couple queries. Because again, this is a toy example. It's only 2 weeks of data. You might be looking at a year's worth of data at even higher fidelity. So that's probably going to be where the art of adaptation comes in for this type of concept. So yeah, that's the database schema YAML. It was generated again. I just asked the LLM to pull the openapi.json from the SQL endpoint, read it, and then cross-check it with the raw data, cross-check it with the ontology, and make sure all the terms were compatible. So with those two things alone, you can do a ton. But like I said, I was pulling out the queries as they came in if they were successful. So I've done this a couple times, force it through a couple things. I even came up with a directive asking the LLM to traverse the ontology to like try to make as many different skip hops as it could, really understand how to leverage it, and then digested all of those queries and kind of came up with effective patterns. So I've got this learned ontology traversal YAML file, which is really just like these are patterns that are common, at least in this context of MES data, but they're kind of templatized SQL queries. So it's just it's a better starting point to reduce failures. But even without this, I think I was only 85% of the queries that were generated and issued were successful. So already that's a pretty low failure rate. And I guess philosophically on all of this, if it's between this and then just two humans or three humans like doing this analysis, they're going to make plenty of mistakes too. So like we should be able to accept like even a 50% success rate because given the fact that the cycle time is so short to like reiterate and the LLM can read and self-correct, um, I don't think we need to worry about absolute fidelity. So that's how I'm kind of skirting the arguments over text to SQL benchmarking. But remains to be seen if this is truly useful. Okay, so these are learned patterns. I'll do a demo without it first, just to show you that it's not necessary, and then we can see if it's any better. Um, the templates I was talking about for the YAML files are in the templates directory. Reference are just kind of notes that I've captured around some of the runs that I did. One was based, I asked it to come up with 30 queries on its or 30 business questions, like natural language business questions on its own, translate them to SQL and run it. It's kind of a report of what it did there. So lots of rich information if you're interested. Utils, these are probably haven't used them. I did all this, by the way. I bootstrapped the whole thing in Claude Code, so it was writing utility functions as we were checking things. I don't know if these are even useful anymore, if they might be. Um, Logging the SQL API just to make sure I catch when things are successful and not successful, if there's an issue. And then I've got a really thin wrapper around starting and stopping the SQL API. They're just a tool that the LLM uses to say, hey, is this running? It's not running. Let me check the status. Let me restart it, yada, yada. Then I guess the other most important piece is a system prompt. And this was developed after I had run it a few times just conversing. And they asked it to reflect and say, look, this is what we're trying to do. Do you get it? It gets it, obviously. Pretty crazy. And then say, okay, write me a really lean system prompt so I can kind of reproducibly start up this type of analysis system. So you can see it's got some architecture notes like how is everything kind of laid out? What are the tools you should be using? That's the API shell script and the query log script to known system characteristics, the analytical approach. And this is important, right? This is really trying to emulate like a collaborative partner on analysis. The initial workflow, just to kind of bootstrap things, success metrics, and then the entry point. So it'll load the context, say, okay, I'm ready to go. Let's do this. So how we actually use this in practice, um, get this out of the way. So I've got Claude code running a cursor, going to clear. We'll start fresh. I'll leave auto accept edits on. Um, and okay, let's just give it at system prompt, which let me look at it again because I think I don't have the learned queries in there. So it'll be fresh. What's it have? Yeah, so it's only got the ontology spec and the database schema. You can optionally load the learned patterns in as context afterwards. So one more time here. So I'm loading the system prompt, checking the API, reading the schema, reading the ontology. All right, so it's going to look at the data boundaries, and this is just saying because it'll try to do time series analysis and other things like that, and it might use the current date to work from, saying like, okay, I want last quarter, but the sample is like arbitrary here, so it's just saying what are the actual dates I have available to look at. Useful. It's already correcting itself. It used the wrong endpoint format. Okay, so now it's got this. Okay, and it's going to check what products. So it's basically just getting the quick lay of the land. You could probably put this as a like a data catalog or another primer to skip this step. But the self-discovery is useful because now it's within its context. It kind of knows how it got there. Okay, so let's go really broad and just say, I, I just got tasked to identify opportunities for improvement in our manufacturing lines. Have all this MES data, but I don't know where to start. What do you think? And what I love about Claude Code is I can toggle plan and execution. So I'm just going to see what kind of plan it lays out. It looks like it's going to charge ahead anyway. Yep, it's gone away and done its own things. So let's just oh, yeah, let's start. Yes, it's a little too eager sometimes. There you go. Okay. So this is great, right? Because you might not even know the questions you're able to ask or want to ask. Maybe you have one in mind, but again, it's about shrinking cycle times and broadening scope. Here's some starter questions, like which bottleneck costs us the most, what's our hidden capacity, what's our quality blind spot. They all look good. So I'll say, let's move forward with all of them. All right, so you can see it's already generating SQL. Let's see what happens. presumptuous saying it's $1 million downtime problem. Yeah, the context and conversation management within Claude Code is hard to beat. I tried building out a system similar to it using Google ADK, and it's good for like one or two questions, but like the long-term planning and however it manages the planning and context, really, really incredible. But I would imagine that this mode of working that Claude Code has kind of pioneered is just going to be a commodity as well. So hopefully you can plug and play in whatever you want. All right, we got them question by question. Okay, so hidden capacity, basically it's saying, all right, our current OEE is not 100%, never is. I think 85% is considered world class. But it's saying, oh, you hit 94% at some period, so technically it's achievable here. So if we look at those percentage points, in gain. If you were to bring everything up to speed to 94%, you've got an enormous additional profit. So obviously it's going to be incremental, but you can see what it's doing. So you'd have to put the right guardrails in. And again, the more context you add is possible, but when you're, looking at an enterprise supply chain, you might say, oh, I'm going to go for a 5% improvement target. I'm going to evaluate it, and I know where I'm going to go on these specific lines. This is interesting. It's telling me the packer is a constraint on each of the lines, and if it's just the worst, or if it's a bottleneck, meaning it's stopping what could be a productive downstream piece of equipment. Material jams, causing a lot and lost margin. It's amazing that it's like getting us all the way there very quickly. And again, the toy data that I'm using is like light. You'd have even more information in an enterprise system. Um, and again, it's going off of 2 weeks of data and then projecting out annually. So that's where you're getting these large numbers here. It's kind of funny. It's fictitious, but the logic is right. Um, Interesting profitability things here. Yeah, quality being a big issue. Scrap, that's a real issue in real life. Um, Cascade failures, this kind of tells you where to focus your preventive maintenance or maybe investing capital for better equipment or training. Could be a lot of things. It could even be the raw materials are not spec'd right, that they're causing jams. Um, yeah, I think you're getting the point here. So then it gives you like a recommended action plan. And again, this isn't really prescribed in the system prompt so much. It's really doing this on its own, which is great. But I guess from here, what you could do is you can offload things to Python for deeper analyses. I've tried that for visualization. It works pretty well. Where I'd like to get is getting the data into, very quick iterative machine learning models if I want to do some predictive stuff. But the fact, again, it's because Claude Code can dispatch to all these different things and it's got file read write. It's almost trivial to do it. So let me see if I can think of an example here. Um, Any visualize the are the issues for premium use um, of data. Now, what happened last time is it's using a temp folder for the data stores, and I actually think it looks like right now it's just going to run it again, which is fine. Or it's doing a new query for the time series or whatever it's thinking about doing. If the data exists, you could, cache it. I'm doing that and kind of get away, but you can make all of this efficient. I think the makings of that are there. What might happen though is a lot of the data side loading is done in a temp folder. So if a visual isn't created in this directory that we're in now, I'm just going to have to find it. Again, you can fix that later. Okay, show me the Python code. Sounds great. Correcting itself. I mean, these are all things that I would be doing in my day job anyway, but at a much, much slower pace. So, I mean, as we get better at these things and cycle times keep shrinking, you could essentially have this in real time and then layer on the agentic component where it's doing these analyses at whatever frequency is advisable, and then saying, hey, someone gets a line operator gets a message saying, go check the packer, or the plant director gets an email saying you should consider putting in for the capital budget this year and replacing this piece of junk. Yeah, it's going to go to temp. All right, let's see what happens. Mhm. Mhm. So what I'll do is after this session, since I haven't done this yet, and it's finding a bunch of like little warts and gotchas, I'll just ask it, add to my documentation, like when you're doing this, would have some, yeah, some type error. You can ask it to try to avoid that. But again, the self-correction's so good, it's almost unnecessary to do that. All right, so it looks like it went to temp. Let's see if we can find it. There we go. There we go. Okay, so we got something. I don't know if it's the right thing, but I think you get the point of where this is going. It can do a lot very, very effectively. Um, okay, so it looks like quality was bad in the beginning, and then maybe a fix was made. Again, it's synthetic data. The whole generative process is all configurable. I can share that another time. But hopefully you get the point of a system like this. Um, Much more effective than just trying to go text to SQL um, out of the gate blindly, or trying to like index business questions. You're using your creative power, the LLM's creative power, its ability to use tools, and its ability to traverse the ontology effectively. So I hope that was interesting. Um, I'm gonna call it there. Thanks.